Let's discuss the properties of radicals. Now, one that I do not have listed here that we discussed earlier is when you have the nth root, the square root, I should say, of negative value, you always factor out. Whenever you have an even index of a negative value, always factor out the even index of the negative one first. Always take that into account first, because you're going to replace the square root of negative 1 with the imaginary number I. Okay, so let's get to these other properties of radicals. The first one is the multiplication property, or the factoring property. If you have the nth root of a times b, you can bust that apart multiplicatively as the nth root of a times the nth root of b. If you have the nth root of tall quotient a over b, you can bust that apart top and bottom, nth root of a over nth root of b, but you have to make sure that the denominator b is not equal to 0, cannot have a 0 denominator. And finally, when you have the nth root of a raised to the m power, you can actually bring the m power to the outside of the root, the nth root of a parenthesis to the m power. Okay, let's try some applications of these with real numbers. We have the fourth root of 32. We can factor that down to the fourth root of 16 times the fourth root of 2, and that's because 16 times 2 is 32. And when we bust out the fourth root of 16, we can rewrite that as the number 2, because that is the same as 2. So we have 2 times the second radical, the fourth root of 2. The next problem is the cube root of negative 16. We're going to simplify that. Well, we can bust out the cube root of negative 8 times the cube root of 2. We're allowed to do that because negative 8 times 2 is equal to negative 16. Okay, now we're going to simplify. The first part, cube root of negative 8, is the number negative 2. That's because negative 2 in parentheses raised to the third power is negative 8. So we've got negative 2 times the second factor, cube root of 2. Next example, we're going to simplify the cube root of 24 times x to the fifth power. Okay, let's bust it out. We're going to actually write as many perfect third powers, bring them to the front as possible. So we know that 24 is the same as 8 times 3, and 8 is a perfect cube, so we'll bring the 8 out in front. We also know that x to the fifth can be broken up to x to the third times x to the second, and x to the third is a perfect cube, so we'll bring that part to the front. And then we multiply by all the factors that are left in the back that are not perfect cubes, the 8 times 3, so the 3's in the back, the x cubed times x to the second, so that leaves x to the second in the back. Okay, so you can check to make sure that what I have under the radical, 8 times x cubed times 3 times x squared, is the same as the 24x to the fifth. Now let's bust it up. Bust up each of the square roots of the cube roots of the perfect cube. So we have the cube root of 8 times the cube root of x cubed times. Now don't bother busting up the stuff in the back, because we put all the stuff in the back that's not a perfect cube. It's not going to simplify, so you can leave it together under a single perfect cube, a cube root. So we've got the cube root of 3x squared. Now simplifying the cube root of perfect cubes, the cube root of 8 is 2 times the cube root of x cubed is x times the remaining portion, cube root of 3x squared. And that is our solution. And finally, we're going to simplify the tall square root of 16y to the fifth over 81y. Now, under the radical, let's see, we can simplify before we go any further. We do have a factor of y to the fifth in the numerator under the radical and y on the bottom. So let's go ahead and simplify that, and we get y to the fourth in the numerator. Okay, so we just canceled a factor of y in the denominator. This is all under the radical sign. We simplify the factor of y with a factor of y upstairs. Okay, so we have the square root of 16y to the fourth over 81. Okay, now we're going to bust up the radical top and bottom, and we're going to actually factor the top. So on the top we have the square root of the number 16 times the square root of y to the fourth, which we can write as y squared squared if we care to. And then the bottom is just the square root of 81. Well, this simplifies nicely. The square root of 16, of course, is going to be 4. And then we can cancel the square root and the square, and the top we get 4 times the absolute value of y squared over 9. Now, do we need those absolute value bars? No, because y squared is always going to be positive. It doesn't matter what y is. When you square that sucker, it's going to be positive. So we do not need the absolute value bars in our final answer. And that's because y squared is greater than or equal to 0.